So the second option I'm going to go over here for creating these networks is the branch networks, and this is a pretty broadly applicable one across a lot of different types of medical or microscopic imaging. So you can take any branch structure and convert it into a network of branches. In this particular case, I'm going to be using this picture of a human brain with the blood vessels fluorescing, or I guess the blood vessels being bright because it's like an angiogram. So like always, you want to make sure that you're using segmented data when you do the actual analysis. So we can try to produce that from the segmenter, or you can do it from whatever segmenting software. Make sure that the images you are loading are in the TIFF format. And then I'm not actually going to go through the whole process of doing this here. But this is like any other time you try to make a segmentation. You always want to just start by doing this, correct it where you want to, have it not make these kind of mistakes. So you just kind of keep doing this until it looks fine. And I've already segmented this one, so I'm just going to pull up that segmentation there. So just as a starting example, okay. So here's one that might be a little messy, and let's look at it in 3D for a second. As you can see, a lot of this junk over here is not very useful. You want to make sure that you always clean up your segmentations after you make them. There's always going to be a little bit of mistakes. So there's several ways to do that. You're going to want to usually do it through the image processing window. You can label your objects, which assigns them values, and then you can filter them by volume if you want, or you can just click on stuff you don't like and delete it. Make sure that it's set to the active image that you actually want to mess around with. So let me just try this here. And turn on the highlight overlay so you see what it's interacting with. So here's the big structure, and then all of the little ones are mostly over here on this side of the histogram. So you can apply this threshold if you want to maybe just keep the big one. Another good option, you can try to run this filament tracer for these kind of filamental structures specifically. So if I were to run this here, it would pretty much just go through the segmentation and try to draw more clean filaments over it. So if we were just going to look at what that looked like in 3D, it's going to go to the cyan channel, but as you can see, a lot of the green junk is now filtered out. And anyway, I'm just going to pull up a more cleaner segmentation that I already have. So let me just load that. Here we go. There's two types of branch networks you can create. You can either create this branch point network. What this will do is it will connect the actual vertices of the branch structure itself. So when we take a look at the network, human cranial vessels here, you can kind of see them here. Here's the circle of Willis, the middle cerebral arteries on either side. That's actually connecting the vertices of the branches. So it's one way to do it. You can also connect the branches themselves, which might be a little bit more intuitive. So let me do that. And then for that one, you would use this branch adjacency network option. Here are some of the default, the default values are usually pretty good. You can sort of read what these parameters mean in the documentation if you want. The only one I'm going to go over is this option. So when it's labeling the branches, it labels them around their branch points. So any structure that has a lot of branches coming out off of it will get chopped up into a bunch of smaller branches. If you select this, it will try to reunify them, and I'll briefly show you the difference in what that looks like. So you're just going to want to run these, and this is not using that. So if I were to color my branches here, they're currently in the nodes channel, so I just do that color nodes option. And you can see this is how it's decided to label them. Let's just go in really quickly up close. So like, for example, this structure, this red one, we've got like a split here because it sees this as a branch. This is kind of not real. And it sees like branches here. So if I were gonna run the reunify one, the reunify option, then instead we would kind of get this. And then something I'll also bring up here is you can also enter a value to remove spines. So like stuff like that little spur over there that it saw as a branch, if you want that to get ignored, you can enter this, and then any structure that's that many pixels smaller in length will get ignored if they're coming off a branch immediately. So let me just run these. And now when we look at this, you can see that like these sort of side branches are a lot less chopped up. You know, and this can be like a good option, but the only disadvantage is it can be like somewhat unpredictable when it comes to like how it's labeling stuff, just because it's kind of a computer making a prediction. It might not be the way that you would intuitively think of it. So, you know, I would recommend maybe just running it, seeing if you like the output. I have this disabled by default just because the default settings have a lot more predictable results. But like, for example, you know, you get larger structures that way. And then these branch networks, once you've calculated them, you know, you can, like before, you can just do analysis on them. You can visualize them. You can make these colored renders. You can community group them. There's lots of different things. And then I'll just like take a look in 3D how this looks. So there we go. Pretty fun looking. You know, and once you're doing this, can be a good way to make figures for stuff. And you know, we can change how these are sort of perceived. We can make them ISO surfaces in Napari if we want. If you want to add a scale bar, you can. So there we go. I didn't actually set the scaling correctly, which is why this person's head is so squashed here. Yeah, and the fun thing is that you can like select stuff, or if you were doing it via thresholding, like let's say we want to know like the largest radii, right? Calculate radii here, and then you can threshold the nodes with that. You know, let's pick some of the big ones. And then instead of applying the threshold, just exit. That will keep your highlight overlay, but it won't actually alter the data itself. And then now when we see this in 3D, you know, you can see those highlights with it. So I'll just turn off the color channels for a second. And we can see like those higher radii vessels have been picked out. So we've got both carotid arteries. We've got the sort of brainstem main arteries here being picked up. So there we go.